Hello everyone. Today we will be dealing with new chapter which is metals and non-metals. What comes in your mind? Some tough stuff, right? So, metals are related to something solid and strong. Well, all metals are not like that. In the chapter, we will be discussing some interesting things about the metals. In this chapter, we will compare physical properties of metals and non-metals first. Then we will go for chemical properties of metals. We will also learn about the basic of ionic bond between metals and non-metals. We will discuss how we obtain metals. We will study the corrosion. Remember, the rust formation we have discussed in chapter 1. Then we will learn about alloys. Let's discuss some physical properties of metals and non-metals. Metals are malleable, which means they can be beaten in thin sheets. This example is aluminium foil we use for packaging of food. Non-metals are non-malleable. Metals are ductile. That means they can be drawn in the form of thin wire. We have seen metal wires all around us. Non-metals are non-ductile. Metals are sonorous. The metals are having ringing sound. The school bell, the temple bell, all are made up of metals. Non-metals are non-sonorous. Metals are lustrous. That means they are having shiny appearances, hence used in making jewelries. Non-metals are non-lustrous. Metals are having high melting and boiling point, having high tensile strength, and they are solid at room temperature. Non-metals are having low melting and boiling point. They may solid, liquid or gas in room temperature. There are few exceptions regarding general physical properties of metals and non-metals. They are graphite. Graphite is a carbon which is non-metal, and it is also good conductor of electricity. Iodine is non-metal and lustrous. Sodium and potassium are metals, but they are soft and can be cut. They do not have tensile strength. Diamond is carbon, a non-metal which is hardest substance known. Mercury is metal, but it is liquid at room temperature. Gallium and cesium have very low melting points. The melting point is so low, but they melt in hand. You see, there are so many exceptions. We really can't define them on the basis of physical properties. We should go for chemical properties. Chemically, metals are substances having 1, 2, and 3 valence electrons. For example, sodium is having 1 outermost electron. Aluminium is having 3 outermost electrons. The elements having 4 valence electrons can be semi-metal or non-metal. The elements having 5, 6, 7 valence electrons are non-metals. Let's discuss some chemical properties of metals. The chemical properties of a metal depends on its reactivity or tendency to perform reactions. Here is a reactivity series of metals. The metals at the top that are sodium potassium, which is most reactive, and below like gold and silver are least reactive. Metals usually react with oxygen to form metallic oxide. Sodium and potassium react vigorously with metal at room temperature. The reactions are very vigorous and metals can catch fire when kept in open. Such reactive metal like sodium is kept in kerosene oil to prevent it from catching fire at room temperature. The chemical equation of the reactions are given below. When 4Na react with O2, that will give 2Na2O. When 4K react with O2, then that will give 4K2O. Magnesium react with oxygen when burnt in air. It forms magnesium oxide. Here is the equation. When 2Mg react with O2, then it will give 2MgO. When copper is heated in air, then copper oxide is formed. Here is the equation. When 2Cu react with O2, then it will give 2CuO. Aluminium also react with oxygen on heating and aluminium oxide is formed. The equation for the reaction is mentioned here. 4Al react with 3O2, that will give 2Al2O3. There is an interesting thing about aluminium oxide, it having both acidic and basic nature. Aluminium oxide as basic oxide react with acid to form salt and water. Al2O3 react with 6HCl, that will give 2AlCl3 plus 3H2O. Aluminium oxide reacts with base such as NaOH to give salt and water. Here is an equation. When Al2O3 react with NaOH, then it will give 2NaAlO2 plus 3H2O. NaAlO2 is sodium salt known as sodium aluminate. Such type of oxides are known as amphoteric oxides. Zinc oxide is another example of amphoteric oxide. Metals react with water. The reactivity of water depends on the reactivity of metals. Metals like potassium and sodium react violently with cold water. The reaction is highly exothermic and violent, and the evolved hydrogen immediately catches fire. Here are the equations representing reactions. When 2K react with 2H2O, then it will give 2KOH plus H2. When 2Na react with 2H2O, that will give 2NaOH plus H2. Calcium also react with water, but this reaction does not produces that much heat to burn hydrogen gas evolved. When Ca react with 2H2O, that will give CaOH twice plus H2. Magnesium react with hot water only. It does not react with cold water. When Mg react with H2O, it will give MgOH twice plus H2. Aluminium, zinc and iron do not react with liquid water. They react with steam and form metal oxide and evolve hydrogen gas. When 2Al react with 3H2O, that will give Al2O3 plus H2. Also, when 3Fe react with 4H2O, that will give Fe3O4 plus 4H2. Copper, silver, gold are less reactive metals and do not react with water at all. Now, we will discuss metals' reaction with acids. Metals above hydrogen in reactivity series react with acid to give metal salt and release hydrogen gas. We have discussed such reactions in acid-base chapter. Here is an example. Zinc is reacting with sulfuric acid and releases hydrogen gas. This is the equation of the reaction. Zn react with H2SO4 that will give ZnSO4 plus H2. There is exceptions considering reaction of metal with nitric acid. The nitric acid do not evolves hydrogen gas on reaction with metals. The nitric acid is a strong oxidizing agent. Itself, it gets reduced to any oxide of nitrogen like NO2 or NO3, etc. But magnesium and manganese react with very dilute nitric acid to evolve hydrogen gas. Metals react with other metal salts which less reactive than it. Suppose metal A is more reactive than metal B. A will do a displacement reaction with salt of B, say Bc. The reaction will be as A plus Bc gives Ac plus B. Here is an example for the reaction. Iron nil react with blue solution salt of copper. Copper sulfate displaces copper and form its own salt ferrous sulfate. Here is the chemical equation. When Fe reacts with CuSO4, that will give Cu plus FeSO4. The color of solution changes from blue to colorless due to formation of colorless solution of ferrous sulfate. Also, brown layer of copper metal on iron nil is observed. Well, how these reaction of metals take place? Before that, let's understand concept of Lewis structure, also known as electron dot structure. Its representation used to indicate the number of valence electrons of an element. It is given as element symbol, which has number of dots as the number of valence electron the atom is having. For example, electron dot structure of sodium metal is given Na with 1 dot because it is having only one valence electron. Similarly, electron dot structure of other metal can be written. Now, we can represent chemical reaction mechanism easily. We studied earlier each atom in order to gain stability wants 8 electrons in its outermost orbit. Metals, as mentioned earlier, are having 1, 2 or 3 electrons in outer orbit. They can lose those electrons in order to gain stability. Similarly, the non-metals having 5, 6, 7 can gain those electrons left by metal. In the process, the metal will get positive charge and non-metal will get negative charge. Unlike charges attract, thus both metal ion and non-metal ions attract each other. This bond formed by ions, hence known as ionic bond. Here is an example of formation of sodium chloride by the same process mentioned above. Here, the Lewis structure formation of few ionic bond formed compounds are given. 2 electrons of calcium atom is transferred to chlorine atom forming magnesium chloride. Similarly, 2 electrons of magnesium atom is transferred to the oxygen atom, forming magnesium oxide compound. The compounds formed by ionic bond exhibits following properties. They are formed by transfer of electrons. They are soluble in water. They conduct electricity in aqueous solution or molten state. They are having high melting and boiling point, hence are solid in room temperature. So, that's all for now. We will continue the chapter in next video. Keep watching and keep learning. Thank you.